Action! Hello everyone, my name is Sandra the Sock Puppet. I am going to teach you all about G-protein coupled receptors, or GPCR. GPCR are an incredible way for water-soluble messengers to pass information to the inside of a cell. Without the GPCR, water-soluble messengers cannot pass through the cell's hydrophobic plasma membrane, so the GPCR is a clever way around that. These receptors are only found in eukaryotes and are the most diverse group of membrane receptors. Humans have more than 1,000 known types of GPCR, each one specific to a specific function. I wonder how many socks have. Anyways, the receptor has 7 components made of 7 transmembrane alpha helices. 1, 2, 3, 4, 5, 6, well, you get the idea. And this is the G protein that is coupled with it. The G protein has 3 parts, the alpha, the beta, and the gamma. Watch out for this alpha component. Right now it's holding on to some GDP, which I'll get to later. But it's important to note that the G in GPCR comes from this GDP. Right now, all of these components are connected to a receptor, but when a first messenger ligand that is specific to the receptor attaches to the receptor, it causes a conformational change. This first messenger ligand can be anything from a photon to a neurotransmitter, as long as it is specific to its receptor. The receptor still has its 7 parts, so we can at least say that's accurate. In reality, the change will be quite dramatic, but all of my drawings are just approximations to help you learn, so let's not get fussy about it, okay? Anyways, after a conformational change, the alpha component moves away from the other G protein subunits to look for an effector protein. The alpha component then binds to a suitable effector protein, and while it does so, it exchanges GDP for GTP. Told you I'd get to that later. And the effector protein takes adenosine triphosphate, that's the ATP, and takes 2 phosphates off to create cyclic adenosine monophosphate, that's the CAMP. The CAMP is a secondary messenger which will activate the protein kinase and trigger responses in the target cell. This can be anything from activating enzymes to opening ion channels. One more wrinkle in this pickle is going to be how there are different types of alpha subunits. But I'm only going to focus on the alpha sub S and the alpha sub Q. If the subunit is alpha sub S, then the effector protein will produce CAMP like I just showed. However, if the alpha subunit is an alpha sub Q subunit, then it will lead to the activation of an effector protein called phospholipase C, or PLC, and the production of IP3 and DAG instead of CAMP. G-protein coupled receptors are very complicated, and there are thousands of different types of them, so this is just a basic pathway of the reaction to get a feel for how it works. Thank you for watching. Okay, we're going to start the